Okay, then the second problem we have, the first thing we want to do is to write a general expression for the slope of the curve. That's just to find dy dx. Okay, so we're going to take the derivative of both sides with respect to x. And on the left side we get 2x, then minus the derivative of xy. And if you recall, the derivative of xy is xy prime plus y using the product rule. And then the derivative of y squared is 2y y prime. And the derivative of 9 is 0. Applying the negative to the parentheses. And once again, our goal is to isolate the y prime. So we're going to collect all the y prime terms together, move everything else to the other side. I'll put positive terms first. So we get 2y y prime minus xy prime on the left and y minus 2x on the right. I'm going to factor out a y prime from the left, and I get y prime times the quantity 2y minus x is equal to y minus 2x. Divide both sides by 2y minus x, and I end up with y prime is equal to y minus 2x over 2y minus x. And that's the answer to A. Next, I want to find the coordinates of the points on the curve where the tangents are vertical. In a derivative, especially in a derivative that is in a rational form, a fractional form, the derivative will be 0 when the numerator is 0, and the derivative will be, or the derivative will be undefined when the denominator is 0. Said another way, the derivative will be horizontal when the numerator is 0, will be vertical when the denominator is 0. And so we're looking for vertical tangents. We're going to set 2y minus x equals 0 so that x equals 2y. Now we want to find the coordinates of the points on the curve where x is equal to 2y. So we're just going to substitute 2y for x in the original function. So we're going to take out any x's and replace them with 2y. And now we're ready to simplify. So 2y squared is 2y quantity squared is 4y squared. 2y times y is 2y squared, plus y squared equals 9. So we get 3y squared equals 9. Y squared is equal to 3. And so y is equal to plus or minus square root of 3. So whenever at the points where y is equal to plus or minus the square root of 3, at those points the tangents to the curve are vertical. So we need to find the coordinates. Now the easy way to do this, again, is to just go back to the relationship that must exist between x and y in order for this phenomena to occur. And since x must be 2 times y, so very simply, my first pair of coordinates is positive square root of 3. I'm sorry, I have these in backwards order though, because x is 2 times y. And if y is square root of 3, then x should be 2 square root of 3, y should be square root of 3. Now when y is negative root 3, then the coordinates are just negative 2 root 3 and negative root 3. Done. So that's part B. We'll go on to part C. I'll scroll down a little bit. At point 0, comma 3, find the rate of change in the slope of the curve. So the slope of the curve is already the rate of change of the curve. Now we want to find the rate of change of the rate of change, which means we want to find the derivative of the derivative, or we want to find the second derivative and evaluate that at the point 0, comma 3. Alright, so we're going to use our first derivative, which we carry in from the problem, and we need to find the second derivative and evaluate that at 0, comma 3. And here we go. This is a quotient, so we'll need the quotient rule, low d high. The derivative of the numerator is y prime minus 2, minus high d low, and the derivative of the denominator is 2y prime minus 1. And that's all over 2y minus x quantity squared. Well, we can plug in the y prime where we see it. We can plug in that original derivative, but it's even easier to evaluate the original derivative and then plug in. So the original derivative is just 1/2. Okay, so I substitute all my values for x, y, and y prime, and you can pause this and work through all that messy arithmetic, but you should come up with negative 1/4.